As NASA just confirmed something that shouldn't be possible. A machine built in 1977, running on less power than the light bulb in your fridge, is sending back data from a part of the universe no human model ever predicted correctly. And in a few months, it's going to cross a line no object built by humans has ever crossed before. This is Voyager 1. And what it just found is rewriting physics, September 5th, 1977. Kennedy Space Center. A rocket lifts off carrying a spacecraft the size of a small car. The mission is simple. Fly past Jupiter, fly past Saturn, take some pictures and go quiet. NASA expects it to survive 4 years, maybe 5. It never stopped March 1979, first close-up images of Jupiter humans had ever seen. November 1980, Saturn. By the end of the 1980s, Voyager 1 had already traveled farther than any human-made object in history. And it was still transmitting. Then in 2012, 35 years after launch, it did something nothing built by humans had ever done. It crossed the heliopause. Here's what that actually means. The sun constantly releases charged particles, the solar wind, and that wind blows outward, forming a massive protective bubble around our entire solar system. Every planet, every moon, every spacecraft we've ever launched sits inside that bubble. The point where the solar wind runs out of strength and interstellar space pushes back, that's the heliopause. It's the real edge of our solar system. In 2012, Voyager 1 crossed it. For the first time in human history, something we built was sitting in the space between stars, and it kept talking to us. But what it started telling us is not what anyone expected. For decades, physicists modeled interstellar space as calm, quiet, a thin, cold void where nothing much happens, a kind of waiting room between star systems. Then, starting in 2017, Voyager 1's plasma wave instrument picked up something that broke that model completely. A persistent, narrowband signal, a constant hum in interstellar plasma that, according to every existing model, shouldn't exist. Not a glitch, not a one-time spike, a continuous signal detected year after year across more than 900 million miles of interstellar space. For comparison, Earth to the Sun is 93 million miles. This hum stretched across 10 times that distance. Researchers publishing in Nature Astronomy didn't hedge. Interstellar space isn't the quiet void the models described. It's turbulent. It has structure at every scale, and we had no idea, because nothing we'd ever built had actually been inside it to check. And this is where it stops being abstract. That same bubble that Voyager 1 just proved is more chaotic than we thought. That's the bubble protecting life on Earth right now. The heliopause deflects the most dangerous cosmic radiation in the galaxy from reaching us at full strength. And what Voyager 1 is telling us is that the environment pressing against that shield from the outside is more violent, more energetic, and less predictable than any model accounted for. We don't fully know yet what that means for the shield's long-term stability. But we now have to ask the question, and that alone is a shift in how vulnerable we understand ourselves to be. Then, in 2023, Voyager 1 nearly died. For 5 months, it kept transmitting, but the signal was gibberish. Corrupted code that engineers at JPL, after 46 years of reading this spacecraft's data, could not decode. The cause: a single memory chip physically degraded after decades of radiation exposure. One tiny piece of 1970s hardware, 15 billion miles away with no repair mission possible ever, the only tool available was light itself. And even light took 22 hours just to reach the spacecraft. Every single test cycle took 44 hours round trip. Send a command, wait a full day, get a response, analyze it, try again, for months. With the knowledge that one wrong instruction sent once across 15 billion miles could end the mission permanently with no way to undo it, JPL engineers didn't fix the chip. They rerouted around it, splitting the corrupted code into pieces, rewriting each one, and relocating them to working memory elsewhere on the spacecraft. Remote brain surgery on a machine older than most of the people performing it. By mid-2024, Voyager 1 was transmitting clean data again. And the first thing it sent back was more evidence of that impossible plasma hum in interstellar space. But the strangest discovery wasn't the hum. It was what Voyager 1 found the moment it actually crossed the heliopause. Models predicted a smooth transition, solar wind fading out gradually as interstellar space faded in, like a river slowly meeting the sea. That's not what happened. At the heliopause, particles were slamming into each other at speeds approaching a fraction of light speed, generating temperatures near 30, note, not inside a star, at the edge of our solar system. Some researchers have called it a wall of fire. Not as a metaphor, then there was the magnetic field. Theory said the sun's magnetic field and the galaxy's magnetic field should be two separate systems, cleanly split at the boundary. Voyager 1 found they're connected through a process called magnetic reconnection, where field lines from the sun and field lines from the galaxy are exchanging energy across the boundary. Our solar system isn't magnetically isolated from the galaxy. It's linked to it. And every model built before this discovery missed that entirely. Now here's what's happening right now in 2026. Because the story isn't finished and the timeline left is shorter than most people realize, Voyager 1 runs on 3 radioisotope generators powered by decaying plutonium-238. At launch, they produced 470 watts. Today, roughly 250, it loses about 4 watts every year. Sometime in the early 2030s, that number drops below what's needed to run anything at all, and Voyager 1 goes silent forever. Of the 10 scientific instruments it launched with, 7 are already shut off. Earlier this year, NASA switched off the low-energy charged particle experiment, not because it broke, but because there wasn't enough power left to run it, but JPL hasn't given up. Engineers are testing something internally referred to as the Big Bang procedure, an attempt to restructure how power flows through the spacecraft's aging systems to squeeze out extra capacity. It's risky enough that they're testing it on Voyager 2 first. If it works, the earliest attempt on Voyager 1 could come as soon as this year, and the instrument that just went dark could come back online. And then there's the date already locked on the calendar. On November 18th, 2026, at 2:16:12 a.m. Pacific Time, Voyager 1 will reach a distance of exactly 1 light day from Earth. A signal sent to it will take a full 24 hours just to arrive. Send a command Monday morning, you won't know it arrived until Tuesday, and you won't hear back until Wednesday. No human-made object has ever been that far from home, and it keeps going. Every hour, another 38,000 miles deeper into the dark. No friction to slow it, no atmosphere, nothing to stop it, ever. Bolted to its frame is something that will outlast the spacecraft itself, the golden record. A gold-coated copper disc carrying greetings in 55 languages, the sound of rain, ocean waves, human laughter, and 90 minutes of music from across human history, along with a map showing exactly where Earth sits in the galaxy. Carl Sagan called it a message in a bottle cast into the cosmic ocean. It will still be traveling long after every city, every archive, every carved name on Earth has turned to dust. There's still one unanswered question sitting at the center of all of this. That persistent plasma hum Voyager 1 has been detecting since 2017 has 2 possible explanations. One is thermally excited plasma oscillations. Significant, but it fits inside existing physics. The other is something called quasi-thermal noise. A different mechanism entirely, one that would force scientists to rewrite the models of interstellar space from scratch. Nobody knows which one it is yet. And answering that question requires either more data from a dying 48-year-old spacecraft, or an entirely new mission built to study interstellar space directly. That mission doesn't exist. It isn't funded. If someone started building it today, it wouldn't reach the heliopause for at least 25 years. Which means when Voyager 1 finally goes quiet, sometime in the early 2030s, the question it raised goes quiet with it. For decades, right now, the only working scientific instrument humanity has ever placed in interstellar space is 48 years old, built with technology older than the personal computer, running on less power than a kitchen light. And it's rewriting what we know about the universe, because it's the only thing we've ever built with the audacity to actually get there and keep going. The signal is still coming, stretched across 15 billion miles, delayed by 22 hours. Carrying proof that the universe outside our solar system is stranger, more violent, and more connected